Hello everyone, my name is Benny and my group member are Vincent and Johnson. So today we're going to introduce the derivative function numerically. Our problem is solve the derivative of function that is given numerically. So if we are given a value of a function instead of its graph, we can estimate the derivative at each point given. So I will introduce a question example 1.
Hello everyone, my name is Johnson and I'm in a group with Vincent and Benny. And so our problem is how to find the derivative from a table. So we need two equations. Equation number 1, C, T, estimate square T plus H minus C, T over H. Okay, then we use this equation for the one derivative of one side. Okay, and then, so this is the equation number 2. T estimate 1 over 2 slope to left of T flux slope to right of T. Okay, and we use the equation number 2 to solve the problem in the middle of the table.
So example number 1, given the table above, A. Estimate f prime 2 using the volume of f in the table. B. Estimate f prime 12 using the values of f in the table.
So example number 1. Okay, that's the graph x and f of x. So it will be 0, 2, 4, 6, 8, 10, 12. F of x will be 10, 18, 24, 21, 20, 18, 15. So our question, example number 1, A. Estimate f prime 2 using the value of f in the table. So because of f prime of 2, which we have to solve 2 slope to get the accurate derivative, which our formula is, okay, our formula is C prime T equals, estimates, not equals, estimate, 1, 2, slope of left plus slope of right. Okay, so right now we plug in the number f prime of 2, estimate sine 1/2 parenthesis 18, which is the f of x, so 18 minus 10 over 2 minus 0, which is the slope of the left side, plus slope of the right side, which is 24 minus 18 over 4 minus 2. And this is the slope of the right side. So will be equals 1/2. If we do the math problem, will be a over 2 plus 6 over 2. Okay, there's not enough space. So from f prime of 2 equals 1/2 parentheses slope of left and the slope of right. If you do the math problem, math 1, 2, 1/2 parentheses a over 2 plus 6 over 2, and on this side will be 1/2 4 plus 3 equals 1/2 7. So our f prime of 2 will estimate about 3.5. Okay, B, estimate f prime of 12 using the value of f in the table. Okay, so because f of prime 12, which is this one, this is only one side. So from the left to the right, this is only the right side. So we don't have to find the two sides to get the answer. So the equation for our formula for this one will be c prime of t equals c t plus h. Let's set off this. L to the right. Okay. Minus c over t over h, which also equals c plus t plus h minus c over t over t plus h times c minus t. This formula also equals y2 minus y1, x2 minus x1. Is exactly the same. The difference is for the second formula is we just need to find one side, because because this table ends with x10 and x12 and the f of x18 and the f of x15. So although we know the graph is going continuous, but the table given us end with 10 12 and 18 and 15 and 18 and 15. So f prime of 12, 15, f prime of 12, 15 minus 18, 12 minus 10. Like what I said before, it's just only one side. You just need using 18 minus 15 and 12 minus 10 will be equals negative 3 over 2, which f prime of 12 will be negative 1.5. All right, thank you.
Example number 2. A. Given the table above, where's the rate of change of fx positive? B. Given the table above, where's the rate of change of f of x negative? C. Given the table above, where does the rate of change of f of x seem to be the greatest?
I'm Vincent, and today I'm going to show you how to do example 2. So first I'll write down a table. Because 3 of the questions in example 2 relate to rate of change of f of x, and we know that the rate of change of f of x is f prime of x. So what we're going to do next is to find the f prime of x for each point in the table. And we're going to use the equation we showed before. And I'll just write down the derivative. So for part A, where is the rate of change of f of x positive? And again, the rate of change of f of x is f prime of x. So what we're going to do is to find where the value of f prime of x is positive. And we can see that from x equals 4 to x equals 8, the value of f prime of x is positive. So for part A, we can conclude that the rate of change of f of x is positive at 4 to 8. And for part B, it's similar to the previous questions, and we're looking for the values that is negative for f prime of x. So it will be from 0 to 3. So the rate of change of f of x is negative at 0 to 3. For part C, where does the rate of change of f of x seem to be the greatest? What we're looking for is the greatest value for f prime of x. So we're looking through the derivative, and we can see that at x equals 7, f prime of 7 is 7.5, and it's the greatest in the derivatives here shown. So the rates of change of f of x seems to be the greatest at x equals 7.
Example number 3. Given the table above, for what volume of X does G prime of X appear to be close to 3? Thank you.
Okay, then here's example number 3. So the tables here. Gx, v prime x, 0.7, 3.2, 3.7, 4.2, 4.7, 5.2, 5.7, and 6.2. And then Gx 3.4, 4.4, 5.0, 5.4, 6.0, 7.4, 9.0, and 11.0. And to solve the problem, for what value of S does G prime X appear to be closest to 3? So we have to find all the derivative of Gx, and then we use the equation 1 to find one side, the derivative of one side. Okay, G 2.7, estimate G 2.7 logs 0.5 minus Gx 2.7 over 3.2 minus 2.7 equal to G 3.2 minus G 2.7 over 0.5 equal to 4.4 minus 3.4 over 0.5, and here's 2. So G prime 2.7 estimate to 2. Got this one. And for the next problem, and we use both of the equation to solve the G prime X in of 3.2. So it should be 3.2 estimate slope to the left 2 plus the slope the right, so 5.0 minus 4.4 over 0.5 closure 0.12 minus 1.2 equal to 1.6. So G prime 3.2 estimate 1.6. Okay, and then we use both the equation to solve the problem in the middle of the table. So we got 1, 1, 2, 3, 3.6. Oh, sorry, 3.6 and 4. Okay, then we found the G prime X appear to be closer to 3 is right here. So the value of S should be 5.2.
So this is our video, and thank you very much for your watching, Leave your comments below, and I'll see you guys on Wednesday.